Hello everyone! In this video I will show you how to create a river simulation with help of Paradigm GPU Accelerated Liquid Solver. The video would be split in two parts. In the first one we'll talk about installation and quick overview, and in the second part we'll create river itself and I will show you how to use native Houdini whitewater tools with Paradigm Solver. Let's start. Paradigm now in open beta, so everyone can download it for free from Theory Accelerated website. Only one thing what you should do is create an account. After that you can go to download and download Paradigm latest version to your machine. When download finished, you should extract files from the archive and go to your documents Houdini folder and create packages folder if you don't have it yet. After that, simply copy Paradigm folder and JSON file into packages folder. That's it. Now you can start Houdini and you should have all necessary nodes. Let's start with creating a geometry node. Dive inside. And if we start typing Paradigm, we will see all nodes what come with it. Let's create Paradigm Solver. It has 3 inputs. We will go through all of them, but first we will take a look into middle one. The name of it is Source Shapes. In tab menu, we will choose Paradigm Source Shapes. This node allows us to create several different things. Default type is source. Let's plug it into middle input of the solver. And as you see, nothing happened. It's because we should go to Source tab and switch mode to Particles. Now we can see that the sphere populated with particles, and if we hit play, the simulation begins. In the Transform tab, we can apply transformation to the source, we can translate, rotate, scale it. At the top, we can switch from constant emission or emission on the first frame. Let's set back constant and go to Noise tab. If you click Deformation checkbox, it will deform our source. If we click arrow, it will expand properties of the noise for the deformation. We can control strength of it, size, and so on. Next one is velocity noise. Basically here we can add a noise for initial velocity of the particles. In Shape tab, we can switch different shapes of the emitter. Let's disable deformation and velocity. And we'll see emitter becomes cylinder or cone or pyramid. Plane will not work here. But what if we want to use our custom emitter? In that case, we should plug particles to the third input of a Paradigm solver. Let's create a test geometry rubber toy. And now we can see that all points of this geometry become emitter. If we zoom it, we'll see it takes only points, but not all volume of it. I will move it up and will display points to show that. If you want to use a volume, we should create a points from volume. I will adjust point separation to get a bit more of resolution. And now all these points will be in the simulation. I will disable jitter scale, maybe it can cause an issue during the simulation. Okay, now we have a constant emission of points, that's why it gives this result. And it's very important to link point separation to division size, it should be equal. And after that, we should create a switch node, so our points will work only on first frame of simulation. I'll create a null and connect it to the switch. And write expression if frame is higher than 1, then it will switch to null. I will add a point velocity node and add curl noise. So now our emitter will have initial velocities. Source shape node as well can be used for collisions. We just need to switch type to collision. And I will switch shape to plane, just move it down, and in Transform tab, I'll change the scale of it. And now this collision plane will work as a ground plane, basically. If we want to create a classical closed bounding box, we should switch shape to box. I will move it up and scale a bit in Y. And now emitter inside, so we should invert the shape. And from now on, we can see that it just closed bounding box. Sometimes it happens that in simulation we want to kill some particles in certain areas. In that case, I will create a merge node and I'll create a new paradigm source shape. And on the shape tab, I will choose, instead of source sync shape, I will leave as it is, as sphere, increase the scale, and as you see now, the particles inside of sphere disappearing. Force tab, allowing us to create a force. There is different types. I'll choose spin, and now inside of shape, we can see how particles starting to spin. I'll increase magnitude to 11 so we can see better. We can move sphere around and see in real time how it's affecting the simulation. Let's choose another type, for example, omnidirectional. It will push particles out of the center of the sphere. As well, we can add noise to the force. For that, we need to click in Noise tab, Add Velocity checkbox. And now we can go to paradigm solver parameters. We have basic one like start frame, timescale, and substep. So we have division size for resolution and maximum particles count. Usually you should be careful with division size and particles parameters. So it can give you a crash if you put wrong numbers there. So if you increase in the division size, don't forget to increase the maximum particles count as well. At the bottom you have information about the simulation. You can see how much memory allocated for it, total amount of particles, and current particles count. In the source tab, you have particle emitter velocity multiplier and incoming fields multipliers for velocity or pressure or custom one. And now it's time to talk about the first input of paradigm solver, where we can attach source VDBs for collision or custom forces. As well, we can use the heightfields for collisions, and we will use it later as environment collider for the river simulation. Let's create a grid and extrude volume. First I'll rotate in X and then extrude it. After that I'll create VDB from polygons. The name should be collision. And we need check fill interior. And now connect to first input of paradigm solver. As I see, I forgot to disable plane collisions. I'll bypass the node. And now we can see that collision is working properly. As well, if you have some velocities, VDB velocities, the name of it should be collision vel with capital V, so Paradigm can understand them. In the simulation tab of Paradigm Solver node, we can choose type of simulation between flip and pick. I will leave flip. Next is forces, gravity, and next one viscosity. To show how working viscosity, I will disable first and last inputs of Paradigm Solver, kill second source shape, leave first one as a collision object, and we'll create new one for sourcing. Leave it as a sphere. Choose in source type particles, change scale, disable ghosting for extrude volume. And for the collision, I will switch shape to cylinder, remove invert shape checkbox, and adjust the scale, rotate it, and move it lower than sphere. Alright, it's working. Now I click on viscosity and we can see that fluid become more viscous. Just keep in mind that increasing viscosity parameter number will slow down your simulation because of calculations. Surface tension parameter can help us to create crown shape splash, and at Gaussian we'll let liquid to collect at the bottom of collider and be more sticky to the surface. Let's change emitter to first frame only to have emission only on the first frame. And I will check at Gaussian. As you see, it's already start collecting at the bottom. Just let's decrease the time scale of simulation. Yeah, now as you see, we have this behavior. Liquid start dripping from underside of the cylinder. Pressure parameter describes how stiff your particles is in the simulation. Collision parameters given basic friction parameter, bounce, how bouncy particles is, and stick, something similar to stick on collision in Flip, in native Flip solver of Houdini. If you click on it, your particles become sticky to the surfaces. Basically, I think that's it what we should know to start the river project. So let's move to the next part of this tutorial. I will create geometry node and call it River FX. Go on Side. And before we go to water simulation, let's first create collision environment. I will do it with heightfields. So I type in heightfield. We'll change size of it. Let's say 20 in X and 50 in Z. I'll decrease grid spacing to 0.1 and create heightfield noise node. Set amplitude to 17 and element size to 20. And create heightfield paint node, plug it to second input on heightfield noise as a mask, and now we can start paint where this mask and noise should apply. Decrease FG value and radius of brush, as well decrease opacity, and start paint it. I'll create another heightfield noise and another one heightfield paint to add extra noise on top. We'll change amplitude to 10 and element size to 50 of the second noise, connect the mask, and we'll paint it. After all, I will apply heightfield distort by noise. We'll change amplitude. We'll change element size to 30 and amplitude to 3 to get extra details. Correct the beat amplitude of second noise. Set it to 12. And we'll make some correction in mask. When we are done with basic shape, we can move forward and create mask by occlusion, heightfield node, adjust minimum occlusion and maximum occlusion parameters. We need it for creation of the mask for scattering stones, and then we'll apply heightfield mask invert node to invert the mask. Next, I create a heightfield scatter. First input, I'll plug heightfield itself, and second one, the mask. Set coverage to 1. I'll display points so you can see better where scatter happened, and decrease outer radius. As you see, now some points scattering on the edges of the heightfield. To fix that, I'll create a volume VOP after heightfield mask invert. Go on Side. create relative to bounding box, connect position, and output one to file, so we can get the position relative to bounding box of the object. Import the mask field, create get vector component to get x and z position values. After I will create RAM parameter, so we can profile it later. Call correct x and correct z. Then create multiply node and multiply mask by these two curves. And output will plug into bind export node for the mask. Let's adjust the curves. I'll copy first one and paste into second one. Okay, now see, these nodes are fixing this issue on the edges. Okay, let's display heightfield scatter, and I can even adjust further the X curve, so stones will be scattered closer to the center of the terrain. Let's create stone instance geometry. I'll create a simple sphere, change type to polygon, frequency will set to 7, and create attribute warp node to add some noise. To create noise, I will use unified noise static. Let's set 3D input 3D noise and sparse convolution, and fractal type to terrain. Create add node and add noise to current position and connect sum to the position output. We'll increase frequency. Alright, something like that. Let's go up and now translate it to the origin. Click on Move Centroid to Origin in Transform node. Next, let's create copy to points, plug instance geometry to first input and to second one, the points from heightfield scatter. Create a merge to visualize both of them, and terrain and stones. Okay, so let's adjust some parameter of heightfield scatter. Find outer radius parameter and increase range for the second value to 2.5. Disable relax points and randomize up and yaw to 180. We can play with quantization parameter also and with seed to find better distribution. Maybe I can even increase the size of stones. Okay, now we have one problem that stones, half of them is outside of terrain. So let's create a small vex expression to correct it. We will add to Y position half of P scale value just to move them up a bit. Alright, and now I'll check again on size of it and check seed values. Next, let's create VDB from polygons. Voxel size would be 0.5. Check on fill interior, create a null and call it rocks collision. Now we can merge heightfield and rocks VDB, so later we can use it as collisions in paradigm solver. Let's create object merge and copy path to the null object. Rename it to collisions. Let's convert heightfield to polygons and extrude the base and create a null and name it terrain. Before we move next, I forgot to name VDB for rocks collision properly. It should be named collision. And now we can create paradigm solver node. Let's connect collisions to first input and create a paradigm source shape. Create a merge node and connect merge to the middle input. Let's switch type to collision and shape to box. Invert the shape and set boundaries. It should be slightly smaller than our terrain. When we finish with creating of boundary collision box, we can create emitter itself. Let's create paradigm source shape again, change shape to cylinder, move it up. Let's rotate it minus 90 degrees in Z-axis, adjust the scale, and move it to the beginning of the river simulation, where water should start emit from. Okay, now we switch mode to particles. And we can add some deformation to the source. Let's decrease strength of it and switch space to object space. Also, we can add a velocity noise, adjusted value. And let's see. Okay, it's simulating, it's colliding, that's good. Only one thing that we have this backside of bounding box collision. If I create a merge node, we see it clearly that it's colliding with this boundary wall. To remove that, we should create a sink. So let's create one more paradigm source shape. Go to shape, tab, and change type to sink. Change shape to box. And let's position it to the problematic area. Okay, now this particle start dying. I will copy this sink source shape to another place as well, so we will not have these unnecessary boundary collisions. I can adjust a bit terrain, so sides of it will be a bit higher than now. And let's simulate again. I will increase resolution and maximum particle count. After that, I'll create file cache node to cache simulation to the disk, check load from disk, file path explicit, and name the cache. Start frame for caching would be 250, because I don't need all those pre-roll frames, and click on Save to Disk. During simulation I got an error, so I have to change a bit division size. I set to 0.035 and particles count to 30 million. And now I can do a flipbook of the simulation. Alright, so now when we have simulation cached, we can do meshing and move forward to whitewater simulation. First, let's do meshing. I'll create VDB from particles node, copy division size parameter and paste it to voxel size of VDB from particles, and paste the same value to point radius scale and minimum radius. Let's increase a bit voxel size. I will multiply value by 0.9. And now I can create VDB reshape SDF and use operation delayed with an offset parameter value 0.5. After that, I will smooth SDF with mean curvature flow and decrease iteration to 3. Maybe I will increase a bit more resolution. Let's leave it at 0.85. Now time to convert VDB into polygons. I'll create convert VDB node, choose polygons and set adaptivity to 0.05. And last thing what we should do is to transfer velocities from simulation to meshed geometry. To do that, I will create attribute transfer and plug into second input simulation, and in points choose a V attribute for velocity. For some reason it's not displayed in the viewport, but in geometry spreadsheet we can see that there is a values for velocity. Next I will create file cache node to cache meshed geometry to disk. I don't need full range. I will use as a start frame 420 and set a pass. Let's create a null called river, and this will be the river geometry. Now time to create loop network where we will do a render. Call it render, go inside and create SOAP import node to import from object level to loops. I will copy terrain, press Ctrl C and press Ctrl V in SOAP pass, so it guided to proper null. For sublayer style, let's set copy SOAP layer into new active layer. After that, we should assign the material. Let's create material library, go inside and create simple gray shader. Click on assign to geometry, put a star, and now shader should be assigned to the terrain. Let's create graph stages to do clean naming. I called world inf terrain. I accidentally connected to the first input, but I should connect it to the second one. I will copy the nodes and copy the path to rocks geometry. After that, copy graph stages and change terrain to rocks. Go inside material library and set darker gray color for rocks. Now we can import the river, copy nodes, copy path to river null, paste it to SOAP path, and in graph stages I will call it FX and water. Go inside material library and change the shader. Actually, I'll create just new one, call it water, and in material standard surface, I'll decrease roughness to 0.02. Index of refraction I'll set 1.33. Transmission to 1. Now time to create camera. I'll create it in viewport, just press new camera and merge it to the scene. Adjust focal lengths and aperture, something like that. Next, I'll create dome light, merge it to the scene, and choose a HDR. Increase a bit exposure, and maybe rotate a bit. Oops, it's translation. We don't need that. Okay, here's rotation. And now I can start Karma XPU. to check how it looks like. Yeah, seems like water not much visible with all these gray shaders for the terrain and rocks, so we should apply some texture, diffuse texture maps. Let's go back to Houdini viewport and let's plug a couple of textures in material. To import texture, you should use Material X image and guide to diffuse texture pass and connect output to base color. If you need to adjust tiling, you should create a node called Material X place to D and create Material X texture coordinates, plug it to text coord input and output of Material X place to D to the text coord of image. And in the scale, we can adjust tiling. I will copy Material X image node, change signature to float, and choose roughness map. Plug it to specular roughness. Copy Material X image one more time and choose normal map. Change signature to vector 3 and color space to raw. After that, we'll create Material X normal map, plug it into the in and output to geometry normal. Let's render. In the water shader, we can enable code. Set index of refraction to 1.33, and in transmission we can set depth to 0.2. Before we start doing shader for rocks with diffuse textures and so on, we should kill UV attribute what comes with particles after heightfield scatter, because it will override it in copy to points, and create after UV for rocks. Okay, now we have UV attribute, so we can apply texture maps to rocks as well. Let's repeat the steps. Create Material X image and set path for file name to the texture, diffuse texture, and plug it into base color. Create Material X place to D if we need to adjust the tiling. And set roughness and normal maps as well, same way as we did before. I forgot to add displacement, so I will copy one more time Material X image, change signature to float and choose displacement map, and we'll plug it to displacement input of Material X displacement node. Found scale value and remove file color space raw, should be just blank. To make rocks color darker, I will create multiply node and multiply diffuse color value by some amount. Let's say 0.5. And now we can create a karma setup. I will choose engine XPU and set path trace samples to 300. Increase reflection and refraction limit to 8 and decrease color limit to 10. As well, I will enable a motion blur. For velocity blur, I will choose velocity blur. I forgot to add displacement to terrain as well. So let's go inside of shader and copy material X image node, remove raw, choose signature float, and set a path. Connect it to displacement and decrease scale value. Let's say it should be 0.07. I think we can do variation for stones for this multiplier, what we did for diffuse color. Let's go back to attribute wrangle and write expression to get some random value per instance. It would be simple random function. And after we created it, we should read it in shader. To do it, let's jump in shader and create geometry property value node. It should stay float, and let's put the name random. Now we can create mix node, choose color, plug random value to mix parameter, and set FG and BG color between 0.2 and 0.8. Now we can multiply it. So now we have a bit more randomness for the stone's color. As well, we can do kind of wet map for the terrain itself. So we will hold one frame of water simulation and transfer red color attribute to the terrain itself, so we can know where it touches it, and then we will use it as a multiplier for diffuse color as a simple way. Of course, you can just do two different shaders and blend shaders with this wet map. I'll just do a simple way for now, but logic's the same. Let's assign black color to terrain and red color to river. Create attribute transfer and find distance value. To hold the frame, let's do time shift node. Don't forget to delete frame expression, so we have only one frame. And now we can create a mask attribute based on color and smooth it a bit to get softer edges. I'll create attribute wrangle, call attribute mask2, it's equal to red color, and after we can remove color attribute from geometry. I'll use remove point attribute function. Alright, and now we can smooth mask attribute with smooth node. If we need to visualize it, we can do it with a color node and just choose ramp from attribute and choose mask 2. I'll increase strength to 20, and I think that's good. Let's import attribute to shader with geometry property value. Type mask2, create mix node, and connect mask attribute to mix input and output of mix to second multiply value. FG color should be something around 0.5 and BG color should be 1. FG color maybe even can be lower. Let's check and render. I will increase exposure of dome light to 0.5, and now we can check in render. I'll go to USD rope and click on render to mplay. Alright, I think now I can do a test and render some sequence of frames, let's say from 450 to 480, and let's see how it looks like. Okay, here it is result. And I think from now we can move on and do a whitewater simulation. To do it faster, I will start a new Houdini, and there I will create from shelf guided ocean, and on top of that whitewater presets, and I can copy those nodes and just assign them to my simulation. We will need these 3 nodes, so let's cut them and paste them on the object level to river scene file. I will change start frame for whitewater sim, dot network, and now we can start set up whitewater source. Of course, it gives us error, so we should copy path to river cache and paste it into object1 path. So as we see, we have velocity field, but we're missing surface field. That's actually what we can just out from VDB smooth SDF. To iterate faster, I will cache it as well. So I will create a file cache node, call it surface field, and save it to disk. I'll start from 250 to 500, explicit path, name it correctly, and press save to disk. Alright, so now we can use it for emission and simulation of whitewater. Let's go back to whitewater source node, create one more object merge, paste path to surface field cache, merge them, and plug them into whitewater source node. As you see, this node shows us not just emission volume, but an incoming VDB fields. Let's disable it so we can see only emitter. I will adjust limit by depth to set minus 0.1 value and adjust the speed range criteria. So let's say it would be from 3 to 10. Disable emit from curvature, disable emit from acceleration, disable emit from vorticity, and click on splash. One important thing that for splash you should have a p-scale attribute. Maybe that's why it's start lagging, because it's by default it should be 1. Let's create attribute triangle because our simulation doesn't have this attribute, I guess. So I will say p-scale 0.05. Okay, and now it should work faster. I'll set it even 0.04. And now I'll just scale a bit emission volume. Let's say 0.55. I will reconnect volumes out. It should be after merge one node. And now we can just cache the whitewater emitter to disk. I'll set correct path, and the frame range should be from 250. And now I can press save to disk. Alright, so our emitter is cached, and now we can proceed to simulation itself. Let's go to dot network. Volume source and emission source pointed to right things, but our limits set incorrectly. I will delete close boundary expression. And now we can create bounding box of our terrain, and this bounding box would be bounding box for whitewater simulation. To do that, just go into river effects, and after convert heightfield, I'll create bound node and call it boundary. Okay, copy that. Delete expression in limit size and use an expression called bbox to get size of boundary. In the brackets we should set a path. Just press Ctrl V and comma dx size, and if we click on it we see it gives us the size of container. Copy to the second one, just change x to y, and in last one change x to z. To get center, I guess it should be 0 anyway, but to get the center, we'll use centroid expression, point to same bounding box, what we created, and use dx to get centroid in x, then replace with y for y and with z for z. Okay, now we have matching bounding box. And time to create a colliders. I'll do the static object node. Let's go inside of river effects, copy 2 points. Here our geometry, set it to subpass, and for collisions we will use VDB. But before that, let's set bounce to 0.1, bounce forward to 0.1, and set almost no friction. Call it rocks. Go to collisions, and in mode choose volume sample. And copy path to rocks collision so we can access the VDB collision. Okay, let's do a merge node and repeat steps for terrain itself. Call it inf, and actually we can use heightfields as well, but just for variety we can create another way. Create a collision source node, call inf, create a null, call it proxy inf. So basically it will give us geometry and SDF collision. Let's set correct path, go in and replace rocks collision with proxy environment. Oh, for some reason I call it PFX. Let's change F to R. Okay, in merge, by default it says left input affects right input, so we should switch order so simulation work properly. Whitewater scale parameter, let's go to paradigm solver and copy division size and paste relative references. Voxel size should be at least twice bigger as whitewater scale, so I just paste same division size from paradigm solver and just multiply it, let's say by 4. Okay, let's multiply by 3. In the emission, I will make a lower emission for first time just to see if it's working. Lifespan I'll set to 1, and I'll decrease the bubbles rate to 0.1. As well, we can add a velocity noise to particle velocity. I'll increase the frequency of it to 2 in each axis, and we can start play. Okay, something not working. Emission not happening, so it means that we missed something. I'll increase emission amount, and still it's not working. Let me investigate what happened. All passes set correctly, so I guess it should be something else. Okay, I found what was an issue. There was one more reference parameter called timescale, and its reference not existing node. So I'm just kill it, and we should copy from the paradigm solver the timescale parameter and paste relative reference to here. So now it should be fine. We have timescale equal to 1. Press on reset simulation button, and now it seems like it's calculating form. All right, so I think it's time to increase the emission amount and do a couple more adjustments in the forces tab. I will increase base advection strength, so basically foam will move with velocity volume stronger. And now we can go to whitewater import node and do caching to disk. I'll use explicit path, load from disk, and set correct naming, call it whitewater cache. Choose frame range and press save to disk button. Right, so simulation is done. And now we can create volume from particles later to render it in Karma. I think I will skip second part of expression for density because I don't need this density depth control. just H. And in rasterize density, this node creates volume from attributes. So I will just maybe increase voxel size. The second part creates a gradient. It's needed for reflective volume shader. So we'll leave it as it is. And now we can copy render null pass and go into lobs to check how it's rendering. Let's copy nodes, plug it. I will change inf to effects and rocks to whitewater. Go in SOP import and replace the pass to whitewater. Okay, we can see in viewport that it's fetched. Now I will create Karma whitewater material. And now we should have a reflective volume shader. Yes, you see it using gradient to calculate a normal. Let's check it in Karma XPU. Alright, so now we can adjust the densities, p-scale and voxel size of whitewater to find better working values. As well, if you want, you can always multiply density and in shader as well, just to create a multiply node right after density geometry property value. I'll change roughness of reflection as well. I'll set 0.1. And when values is working, we can set output picture pass and do a karma render. And I'm accidentally bypass rocks geometry in lobs, so I need to reconnect it, so rocks rendering as well. This is the final result of this tutorial. Basically, maybe you can work on timescale to increase the timescale of simulation to make water run faster and play with foam settings and so on. But this is a basic idea how to work with Paradigm and native whitewater solver in Houdini. Hope you enjoyed.